This is video 20. In this video, we present an application of the toolbox. We aim to present here a technical result which will be used later in the proof. This result is done in 3 parts. The notations and definitions done here and in the following video are only useful to prove the result of the third video of this part. In this first video, we introduce the decomposition of an extremum simple arc in elementary arcs. Consider a simple B-infinite window W which is not a cycle. This window is in gray. The graphs G1 and G2 are the cut of the grid associated to this window. Consider a simple positive extremum arc A. This arc is hatched. Now consider the index J1 which is the smallest index such that the edge from AJ1 to AJ1 plus 1 does not belong to the window. In this example, J1 is equal to 5. Consider the index J2 which is the smallest index strictly greater than J1 such that the position AJ2 is in the window W. In this example, J2 is equal to 17. Consider the index J3 which is the smallest index greater than J2 such that the edge from AJ3 to AJ3 plus 1 does not belong to the window. In this example, J3 is equal to 20. Consider the index J4 which is the smallest index strictly greater than J3 such that the position AJ4 is in the window W. In this example, J4 is equal to 31. Consider the index J5 which is the smallest index greater than J4 such that the edge from AJ5 to AJ5 plus 1 does not belong to the window. In this example, J5 is equal to 31. Consider the index J6 which is the smallest index strictly greater than J5 such that the position AJ6 is in the window W. In this example, J6 is equal to 42. Consider the index J7 which is the smallest index greater than J6 such that the edge from AJ7 to AJ7 plus 1 does not belong to the window. In this example, J7 is equal to 45. Consider the index J8 which is the smallest index strictly greater than J7 such that the position AJ8 is in the window W. In this example, J8 is equal to 68. Consider the index J9 which is the smallest index greater than J8 such that the edge from AJ9 to AJ9 plus 1 does not belong to the window. In this example, J9 is equal to 70. Consider the index J10 which is the smallest index strictly greater than J9 such that the position AJ10 is in the window W. In this example, J10 is equal to 80. Consider the segment of A from index J1 to index J2. This segment is an elementary arc of G1 called A1. Consider the segment of A from index J3 to index J4. This segment is an elementary arc of G1 called A2. Consider the segment of A from index J5 to index J6. This segment is an elementary arc of G1 called A3. Consider the segment of A from index J7 to index J8. This segment is an elementary arc of G1 called A4. Consider the segment of A from index J9 to index J10. This segment is an elementary arc of G1 called A5. Remark that the arc A5 is consecutive to the arc A4. The arc A4 is consecutive to the arc A3. The arc A3 is consecutive to the arc A2. The arc A2 is consecutive to the arc A1. Then these 5 arcs are a decomposition. This decomposition is called the decomposition of the extremum arc A in elementary arcs. Moreover, all these arcs are positive. Note that, unlike the decomposition in extremum arcs, the arcs here are not necessarily strictly consecutive. For example, arc A2 and arc A3 share a common position. Now consider the dual decomposition of the window W associated to this decomposition. Moreover, consider the concatenation of the finite dual segments and the arcs of the decomposition. We almost obtain the arc A. By adding the beginning and the end of the arc A to the previous path, we obtain the arc A. A decomposition in extremum arcs is useful to decompose an arc into segments of the window W and positive elementary arcs. Now we proved that for any positive extremum arc, there exists a decomposition of this arc in elementary arcs. Suppose that by using our method, we obtain 4 elementary arcs such that each arc is consecutive to the previous one. But suppose that A5 is not consecutive to A4. In this case, a position of the arc A belongs to the interior of A4 whereas its last position does not. Then arc A is not simple, which is a contradiction. Let's go back to the previous configuration and suppose that A5 is consecutive to A4. But suppose that A5 is negative. Then the segment of A between these two arcs intersects with A5. In this example, A70 and A84 are the same position and thus A is not simple, which is a contradiction. Then for any positive extremum arc, there exists a decomposition of this arc in elementary arcs.